analytics. I would say let's wait a couple more minutes because lots of times people get in just a little bit late. I think it would be probably beneficial. So in the meantime, while we are waiting, why don't we just meet each other? Maybe somebody is brave enough to tell us who they are, where they're from, and why they're interested in learning more about this program.
I guess I can go first. My name is Nikita Yachenko. I'm very curious about data science in general, network analysis, neural networks, and artificial intelligence. I am currently working and am looking to expand my knowledge base with potentially going into a master's program. I reside in Moscow, Russia.
Excellent. So you're looking for an online program or an offline program?
That would be one of my questions, definitely, because I'm exploring different avenues to pursue education. And I know for sure that there are plenty of online programs, but I was curious if there are ways for me to be on campus as well when like after work or something like that.
Okay, excellent, excellent. Well, we do have two programs. One is online, one is offline. They're practically mirrors of each other. So you will have a choice, like everyone actually. Should you choose to join either of the programs, either online or offline. So
which one is, so is the first one online or the second one online, or which one of the two?
Master of Data and Network Analytics is an online Coursera-based program. Applied Statistics with Network Analysis is an offline program, which is called MASNA. That's our original offline program. I know the names probably don't talk much about data science, but I will talk about that just a little bit because I think sometimes there is that confusion about the terminology, what is called data analytics, what is called data science. There are lots of memes going around trying to compare the two. And some people say that, you know, if you want to know data science, you need to know Python, and data analytics, it's R. They're all wrong because it's all about data. And what you do with data becomes largely relevant because the tools of working with data are widely available. So the difference is what you learn to do with those tools. So in our programs, we do talk a lot about Python and other languages, and we do study machine learning and including neural networks. And I will show you some of the samples of the courses. And I want to say that the original term data science was actually coined to name statistics, the field of data analysis, call it data science, to highlight the fact that there is a more scientific approach to analytics than there was in the past. Well, it so happened that computer science departments grabbed that term and turned some of the computer science programs into data science programs, but we'll talk about that. Anyone else? We have about a minute or two who can maybe share something with us. Okay, that's Umut. Am I saying your name correctly? 5G network researcher Turkey, master's degree and half graduate in a year. PhD programs. Well, in our laboratory, we do have some PhD students. Well, not some, we have 10 of them. So we can talk about that a little bit too. Some of the master's PhD track programs that we have available. So yes, I will try to answer your question as well. Anyone else? All right, well, let's go ahead and start. If somebody joins us, that would be great. If not, that's fine also, because this is the first official Open Doors event for our program jointly with Coursera platform. We're going to have many more. We plan to have them every 2 or 3 weeks, and most of our programs will be masterclass programs where, open doors, where myself or actually people who work in our laboratory will teach you some of the interesting tips and tricks of working with data. So you don't feel like you've wasted time coming over, and you will get to learn a little bit more about what we teach in our program. My name is Valentina Kuskova. I am the academic supervisor of 2 master's programs, Master of Data and Network Analytics. This is the new program Mdna that we're opening on Coursera platform, and the original master's program Applied Statistics with Data Analysis. They're mirrors of each other. We call them different names so that people can distinguish between the two. Because you can't be enrolled in both programs, it has to be one or the other. But content-wise and possibilities-wise, you will have lots of the same options. And I thank you for being here. I think that all of you have lots of options, both online and offline. And I want to thank you for taking time to learn about ours. Right now, you're facing probably difficult decisions. First of all, for many of you, it's a decision of, do I even go back to school? For some of you who have decided to go to school, the choice is still rather difficult. Which program do I choose? So the question is, we'll talk about the programs, of course, but the first I want to talk about that decision making, because it is a difficult choice that you're facing. And I think your choice is even more difficult than it was 5, 10, 15 years ago because of the availability of online education. And not all programs are created alike. You know that quite well. So let's talk about decision making. I'm going to run a very quick poll. This is completely anonymous, and those are 3 questions that I want you to answer, and we'll talk about how you make decisions. Don't overthink, just answer as quickly as you can. We have our first answers coming up. Okay. The answers are starting to come in.
Hello.
Yes.
This is Lambert from Rwanda. I'm happy to join you to hear more about Master of Data and Network Analytics.
Excellent. We're running a quick poll right now about making decisions. So if you haven't answered questions already, please do so. And then we'll talk about that. Okay.
You are receiving the questions?
The questions, the poll is open. So it's right in front of you.
Okay, because I entered being late, so maybe because I don't know how you started, but if you are keeping presenting, so it's okay. The more you speak, the more you tell us something to say, I'll be ready to do that. I have some questions to ask.
Okay, excellent. Well, if you entered late and you don't see the poll in front of you, that's fine. I will continue talking as soon as people answer. So I will go ahead and probably stop the poll now because I think everybody who wanted to answer has answered. So I end the poll and I'm going to share the results. Well, this is actually quite interesting. I mean, only 18 people answered, but that's interesting, right? Because 44% said that the letter K is more frequently met in the first position, 56% in the third position. With heads and tails, we did have three who have made the choice of the first or the second combination of letters. And 12 people said that they're the same. And Mary works in the bank. She's a bank teller, or she is a bank teller who's active in a feminist movement. Okay, so let's look at the results. It's actually, I think, the first time ever that I conduct a poll like that, where I don't get the results that, at least in the majority, correspond to what the previous similar tests have shown. So as far as the decision is concerned, decision-making letter K is more often present as a third letter in English language words. These are the results of an actual test, and this was heuristic for judging frequency and probability. This is the work of Kahneman and Tversky. Those are the people who got the Nobel Prize for their work on cognitive biases. Majority of people would say that letter K is first met in the first position, and that's called availability heuristic. In our case, that wasn't quite the same, right? So the third letter won, and that's wonderful because you were absolutely correct. As far as coin toss, the chances, of course, of the two combinations are the same, and majority of you said so. And whether or not Mary is a feminist, that's actually also not so fast. Again, research shows, and this is Kahneman and Tversky in 1982, this is also a well-known study that shows that when present with that exact question, majority of people would say that Mary is a feminist, actually a feminist bank teller. That is called a conjunction fallacy. Yes, she's a bank teller, but we have absolutely no information to assume she is a feminist, right? So there is an intersection of feminist bank tellers somewhere here. We have some bank tellers, we have some feminists. Interestingly enough, as Kahneman and Tversky point out, lots of people would assume Mary is a feminist just because she was active in some political movements in the past. So why is it that when we make decisions, we sometimes make decisions that are not optimal, right? So like I said, you've done better than all of my audiences in before, and actually better than 90, here we have 90%, right? The people who said that Mary is a feminist. In the study of Kahneman and Tversky, you've done better than those 90% of the population, right? Well, actually, it turns out that we do have issues with decision-making. You happen to be in the minority, because not only in personal decisions, but in business decisions as well, people don't always make the right choices. For example, strategic decision-making is considered to be a foundation of solid business, but more than half, 50 to 90, in some cases, almost all, right? 9 out of 10 strategic initiatives fail. And some of those failures are classic, and I'm sure you have probably heard about that. Western Union is known now, I think, if you have tried to send money from one country to another, this is considered to be one of the most reliable company to send money abroad. But it used to be a telephone company, and they have refused to, telegraph, they refused to buy a patent for a telephone for $100. So it was actually not that much if you consider how much money they could have made with that simple device. Or the Beatles that were rejected by London's Decca Records a while back. Or Ross Perot was offered to purchase Microsoft for 40 to 60 million. And now it's worth over $300 billion. I'm sure Bill Gates is very happy that he didn't sell it at one point to Ross Perot. So, so how do we make decisions, right? It's actually a very complicated process. When we think about everything we do, actually everything we do and everything we don't do is subject to some decision made at some point, even by us, right? And decision sciences is an entire field of study. It's actually, you probably would not be surprised, but decision sciences is based a lot on data. We'll talk about that, right? But the decision-making process is extremely complicated from the neurological point of view. So it's not just the cognition process that we go through. It's hormones and emotions, because there is a lot of what we call affect, which, when people make a decision under affect, right? Under the influence of very strong emotions. Hormones and emotions influence our decision-making, but worse than that, actually, it appears that our brain makes a decision without us. Here's a link to the study. In fact, all of the claims that I make come with a link, and you can check them later if you want. So here is one claim that our brain makes a decision up to 8 seconds before we become conscious of that decision. So there is a lot of neural network processing, because our brain is a major neural network. There is a lot of neural network processing of which we're not aware, and decisions are being made on the basis of previously available information, including some of the heuristics or shortcuts that allow us to make better decisions. But unfortunately, some of those shortcuts and heuristics are not the best, because 4 out of 10 adults in their personal life regret decisions they have made in the past, especially towards the end of life. So almost half of us are not happy with the decisions made. So does that mean we're doomed to fail, right? So our decisions are subject to, like I said, cognitive biases, the availability heuristic, the conjunction failure, and as you can tell, hundreds of others. This lecture is not about cognitive biases, even though it's a fascinating field in itself. It turns out that our failure to make correct decisions can be reduced to 2 mechanisms: information deficit and information neglect. We either don't have enough information to make the appropriate decision, or we ignore. And by we, I mean that thing that sits inside our head and makes the decision, the neural network makes a decision 8 seconds before we're actually aware that it's making a decision, right? That's called information neglect. And the question is, are we doomed to fail? If 90% of business decisions are failing, and if 4 out of 10 adults are not happy, well, it turns out that one of the mechanisms, information neglect, is something we can do something about, right? So the fact is that the information is not missing. The information is out there. It's just not easily obvious. The information is present in the form of data. So when we talk about data science or data analytics, it's making sense of the world around us. So when you're making a decision about which program you want to join, think about what is it that you want to do. Because there are lots and lots of programs out there in data science and data analytics. Each one of them has a special promise. They will teach you very specific set of skills. So ask the academic supervisors, ask the students what they're working with, because I am personally confused. I've been teaching statistics for 20 years. I'm confused about all of the terms that are being used. So in our programs, in our 2 programs, we very specifically teach students to make sense out of data and to make better decisions based on data. So this is something that we teach you how to do, right? So the tools that we use, and there are lots of tools out there. And then the special type of thinking that we can develop. So the very basic, the foundational promise of our programs is that we start all analytics from the problem at hand, not the instrument, not the tool. It's not machine learning versus neural network. No, it's not like that. It's a problem at hand, and what questions can we answer by solving this problem, and what tools should we use in order to answer those questions. So just running ahead a little bit to finish this talk about decisions, I want to say that we do offer a course in contemporary decision sciences. It is a set of modern decision-making tools, mostly from applied mathematics. It does use the elements of statistics, computer science, operations research, and some additional tools that, of course, are not listed. The business statistics, of course, is the foundation of all of that decision making. So making an applied sense out of the data that we have. So we do have contemporary decision science as an integrated perspective, and we do have a separate business analytics track that allows our students to learn the tools applicable in the business today. So we do prepare students for academia. About a quarter of our students go on to best PhD programs in the world, including Oxford, but quite a few go into business and they use the tools they learn to make everyday business decisions, hopefully with a better success rate than 90% failure rate, okay? So I want to stop and just give you a chance to ask questions before I move on to a quick example of how you can use this problem-driven approach and a multitude of tools at the same time to answer a question about business effectiveness. But do you have any questions, anyone? Please feel free to ask. Please feel free to also enter your questions in chat. We do have two people in this session who are helping me out with this Open Doors event, and they will either ask the questions or they might be able to answer them themselves in chat. So feel free to interrupt at any time and with any questions you might have, okay? So let me show you a quick example so that you understand what I mean by problem-driven analysis. So you probably have heard a lot about the fact that data will change the world, right? So it's all over the place with a lot of different promises and lots of people are running around with the term big data. Well, not anymore, but they used to. And they're saying, well, there are so many ways in which data will change the world. The question is, how will it change the world, right? Well, it turns out that here's one simple case. Let's assume there is a set of best practices. What if we can say that we have a set of universal techniques that can, in business and management, that can make any company effective? Now, this idea was born about 20 years ago, or reborn, because the idea of best practices has been in business for quite some time. But so a new stream of research was generated by Bloom and his colleagues out of London School of Economics. Most of their work, though, is not published in academic journals. It's published as industry reports and white papers because they were doing their work as consulting. So the task is to find the determinants of those causal relationships between the practices that managers and CEOs employ and the organizational effectiveness in the long run. Now, originally it started as a lot of promise, but very quickly Bloom and his colleagues have realized that, yes, it's in principle a brilliant idea, but it has lots of problems. Well, we have seen this problem with an example of a Russian energy sector. The company came to us with a question, and that question was concerning a set of Russian energy distribution company, electricity distribution companies. So it's actually a very lucrative sector, or you would think, right? Because the business practices are standard. All the equipment is standard. The industry is very robust to changes in business cycles because no matter what happens with the economy, we turn the lights on, we power up our devices, we now have our Zoom, right? We need power. So no matter what happens, COVID or not, and actually at times of COVID, we need power even more. The clients are loyal and there is stable demand, but it turns out that out of 38 companies that, big companies that were analyzed, there was a very different level of financial effectiveness. Some companies are generating lots of profits, some companies are nearly bankrupt. So how is that possible? Well, I want to say that typically there is a standard analysis approach to problems like that. I myself have spent 16 years in the United States where I got all of my education, and 8 years in the States I worked in the corporate sector. So I have one of my first degrees is MBA, Master of Business Administration. And so I know that the typical question of interest or the typical variable of interest is financial indicators, how well the company is doing financially, right? And then there are other variables such as labor productivity, costs, assets, other investments, company's legal status, size, and similar variables that we call standard independent variables, right? And most of the analysis that's done in the industry is done with linear regression approach. Now, if you don't know what's linear regression approach, don't worry, because in our program we'll teach you. But it's basically the search for a linear relationship between a large set of indicators and dependent variables, or the variables of interest, such as financial indicators of a company, financial performance. And when all that standard approach was applied to this particular Russian industry sector, there was a complete lack of halfway reasonable answers as to why one company is more effective than the others. So it's actually a standard result. So when you take a standard solution, you get a standard result. It's a very low level of explained variability, and there is practically no statistical significance. So in reality, actually nothing is standard, because linear regression is not the best tool. And when you're looking at the problem, not the standards, right, to analyze it, we can actually realize that a different set of instruments is required to answer this question. We used a special tool for effectiveness evaluation called data envelopment analysis. And we found a set of efficient or effective companies, but that was not enough, right? We wanted to go a level deeper to explain why they're effective. So it's one thing to calculate effectiveness. It's completely different to understand why. So we are looking at this problem from a multi-level perspective, because we take this dependent variable, the financial effectiveness, but then we also do additional analysis on the regional level, which makes it multi-level, right? So it's not the whole country level, it's not one company level, it's meso, we're including the regional level. And we look at the investment attractiveness of region, just to see how much capital is flowing in. Then we are also doing another analysis. So we already have looked at data envelopment analysis for figuring out which companies are more effective, but then we're doing clustering based on the results of that analysis. And with that additional analytics, we find the meaningful difference between clusters. So if before we had no idea what's going on, then now we have actually extracted 3 different clusters where the companies happen to be very similar to each other inside the cluster and very different outside the cluster. So the first cluster was companies with low level of long-term investments, the second low level of economic value added, and the third is low labor productivity. Maybe that's not that relevant, but what's relevant is that standard analysis gives us a very low level of what we call explained variability. Basically none. So here it is R squared of, I don't know, 1/1,000,000th of a percent. When we do this multi-level modeling with better research question formulated, finding additional variables, doing additional cluster analysis, and then doing linear modeling inside those clusters, our variance explained goes up, I don't know, 1,000,000-fold. We explain almost 70% of variability. So when we talk about this data science approach, right, because data science is science about data, right? We have multiple tools that we can use, and these multiple tools allow us to find the best solution. So back to decision making. I want to finish this part because I want to say that all decisions, business or personal, should be based on reliable, relevant information, facts from reputable sources, sources you can trust, but also deep analysis. Because simply gathering information is not enough. That neural network inside our brain is subject to cognitive biases and heuristics or shortcuts, right, that our brain makes without us realizing that. So we do need the state-of-the-art analytics, that would allow us to overcome those biases and make the best decision. I want to say there are lots of tools, but tools are not enough. Just simply because you learn to program in Python does not mean that you have advanced analytical skills. I see it lots of times when I meet a very efficient programmer who can write very quick code, but they don't really know what they're doing with that code. They're developing yet another tool, but what's the essence of the result that comes out when you use that tool? This is something that you absolutely need to learn no matter which program you go into. So both of our programs offer the best of both worlds. We teach you the tools and we teach you the skills to use those tools. We change you to think differently about the data. I can guarantee you that no matter what happens after 2 years in our program, you will never think about data the same way, because we not only teach you the complex approach, we talk about data relationships, and that's network analytics. That is a major part of our program that only very few programs in the world actually offer. So any questions before I move on to who we are?
Excuse me. Thank you for this presentation. So the moment you are explaining this part, I was wondering the kind of relationship with machine learning. What are the similarities with this thing of data analytics and the machine learning?
Well, machine learning is just a tool, okay? Machines process the information very, very quickly. And machine learning is only as good as the data you feed into the machine. So basically, you show a machine a variety of different combinations of variables, and you somehow say, well, you teach the machine, right? There's that training set that we call, there's training set, there's testing set. You take some data and you try to use different instruments to teach the machine how the data should actually aggregate together. One of the simplest machine learning tool, one of the first, is regression analysis. So the first thing people did to teach the machine is to actually taught them regression, right? Machines know how to do regressions quite well, and they can extract the meaningful formula from the otherwise disjointed data. But it's just a tool. And some tasks that we do require machine learning simply because the amount of information that needs to be processed is not feasible for any other instrument. And the number of tasks that machines can do is increasing every day. So there are lots of things that machines can now do. But I want to say that no matter how fast or how good machine is, it's still limited by the data you feed into it and the training that you do. So it still requires human beings. It still requires our creativity, right, and our own neural network in order to be able to be trained properly. So it's just an instrument, and this is an instrument that we use in our analysis when appropriate. Machine learning is excellent for complex predictive analytics when you need to, let's say, build a very complex forecast. You can do that better with machine learning, with a neural network, than you could do with some other tools. So we teach you when to use different tools, right? So, but it's just a tool. There is nothing magical. There's nothing special about machine learning. Like there is nothing special or magical about big data. Big data are data, just big, right? So if you know how to work with data, you will know how to work with big data. You just have to use additional tools to process it, to store it, to clean it up. But there is nothing magical about it. So I think it's a very common tendency in our society in general to focus on the tool as opposed to an approach and the problem-driven attitude towards data analysis. So don't worry about the tools. No matter the tools you learn today, they will be irrelevant tomorrow because more and better tools will come out. What you need to do is you need to learn how to think about the data so that you can use all the new tools that will be coming up in the next 3, 5, 10 years. Okay.
Thank you so much.
All right. Well, let me tell you about who we are actually. I'm the head of an international laboratory for applied network research. It was opened at National Research University High School of Economics in Russia. For those of you who are international students, HEC University, or just HEC, how we call it, is one of the best universities in Russia. It's definitely top 3 in almost all sciences. It's consistently the best in social sciences. And our laboratory, even though we do networks, we are part of Faculty of Social Sciences, not because of what we do, but because of just similar bureaucratic reasons. And we were founded by Professor Stanley Wasserman, who at one point got his PhD from Harvard, but together with Professor Ferligoi and Professor Mdna and some other enthusiasts of network analytic methods, he was one of the people who have popularized network science and social network analysis. This development of the field of social network analysis started really in the late 70s, early 80s. And so Professor Wasserman is well known in the community. He has published some of the best known works and models in network analysis, and the huge book that we call the Bible of Network Analysis. So we were very lucky to have him on board when we started our laboratory. Our laboratory is a full-service think tank. It is the largest network laboratory in Russia, both in terms of the number of people that are employed. We have over 30 researchers. And in terms of the work that we do, we obviously do research. We have by now developed a school of applied network analysis. We have lots of research groups, and we have actually popularized network analytic methods. And network analysis is being taught not only at every level of education, bachelor's, master's, PhD at Faculty of Social Sciences at HEC, but in many universities throughout Russia, because we have traveled to different universities with our presentations. We have 2 standalone master's programs. Again, the traditional offline program, Applied Statistics with Network Analysis, and now a new program on Coursera that we're launching in the fall of 2021. They are mirrored and they're structured a little bit differently simply because it's online versus offline learning. But students who will join the online program can still be a part of offline community. They can visit campus if they want to. And I will talk about the possibilities as well. And in addition to education, where of course we do workshops, we have lots of seminars and training sessions, we also have a consulting center. Inside the consulting center, we have a student-run project that's called Analytic Workshop that offers free consulting services, free statistical consulting to HEC faculty and students, and actually the broader community. And we also have fee-based consulting for major clients. Among them are some of the largest companies that I'm sure you have heard about. We have several official partners, including the International Network for Social Network Analysis, SAS Corporation, which is a major company that produces data analytic software, and of course the academia. We do have partnerships with Indiana University, where I got my PhD and where I studied under Professor Wasserman, and of course University of Ljubljana. We also have a partnership with a laboratory at Northwestern University. So we are tightly integrated in both the academic and the business community. So our students have a chance to also become a part of that community. Especially with Ljubljana, we have more than just scientific supervision. Our partnership includes mobility, so we go back and forth. Both our students and faculty travel back and forth, well, with the exception of 2020, when nobody traveled anywhere. We also collaborate on research projects, and we organize scientific events. And of course, education, lots of faculty members from Ljubljana, and there's some of the world-renowned professors teach in our program. Now, inside our laboratory, we have several research groups. I hold the Network Science and Analytics group. Professor Dmitry Zaitsev supervises policy network science. Professor Daria Maltseva is responsible for networks and sociology, and Professor Irina Zangieva works with network methodology in social sciences. This is the team of our analytic workshop. That's our pride and joy. students that have grown inside the lab from bachelor's level all the way to PhD. Currently, we have 10 PhD students in our laboratory. So that's quite a bit. It's almost like a separate little program. And basically, as part of what we offer, we have these two master's programs that I want to talk a little bit about what they offer in terms of course, decision making, right? First of all, I want to say that the challenges of data that are becoming more and more available. You probably know that 90% of all data available to us today has been generated in the last 2 years, okay? So the amount of data that we have available in the world doubles every 5 years. So with that growth of data out there, of course, you need to have the state-of-the-art tools. As I said, as soon as you learn the tool, it becomes obsolete. So what you need to do is learn not the tool, but the approach of learning a new tool and applying it to real life problems. Then, of course, we have the largest network lab here, and then we do have world-renowned professors. One of the biggest advantages that our programs have is we don't have a lot of faculty on staff here at HEC. Most of our faculty are professors from all over the world that travel to Moscow, well, except for 2020, right? They travel to teach the courses, and they will be recording their courses for Coursera. So when you go to Harvard, you only have Harvard professors. When you go to Moscow State, you only have Moscow State professors. In our program, you have a variety of professors, top world-renowned researchers from all over that come together to offer the best that there is in data analytic education. Now, we teach you the skills that markets demand. I'm not going to talk about all of these models, of course, because there's so many of them. When the program first started, we didn't have machine learning as a course. 5 years ago, machine learning hasn't taken off yet. Of course, it was already becoming popular, but it didn't yet have the reach and the magnitude it has today. So we quickly switched, and now we have machine learning. Same with neural networks. We didn't teach them right away. We teach them now. So we quickly adapt because it's a small program. We're not a part of the faculty. This program is part of a research laboratory, so we're completely independent from what is going on in the larger departments where it takes so long to adjust and adapt. And because we invite professors to teach specific courses, we can quickly adapt to what the market demands. In terms of the programming languages, that's everything that is required out there. So it's really anything you want to learn. If you want to work in Python, you can. We had students that were so bent on only wanting to learn Python, we offered R, because R is actually the language for statistical computing. In my humble opinion, R is still better for data analysis than Python. Python is a universal language, and you can't be everything to everyone. R is better for data analysis. Yet some people want to learn Python, fine. You can do everything you want to do in Python. If you want to learn R, fine. If you don't want to learn R or Python, you can work with ready packages. We offer SAS, and SAS has an excellent academic edition where you can learn everything you need to learn about SAS. It's a free environment, you don't have to pay for that. We also offer other programs such as Orange, which is the best tool for data mining. By the way, Professor who wrote Orange is the one who is teaching it for us, Professor Mdna. Now, you also, of course, we have specific network analytics software. And for example, software it's called PIAC, that's used to for analysis of big networks. How big? 10 billion big. That's the only non-commercial software that can take networks of that size. Professor who wrote it, Vladimir Batagel, is the supervisor of our laboratory, and he's teaching networks courses for us. So, like I said, we bring the best people from all over the world to teach you the skills. Now, there was a question about can students present diploma work, and do I have some advice to choose academic supervisor? Of course, the students who study online can and should, of course, do their diploma work. It's a part of the master's program. And as far as choosing a supervisor is concerned, I would say that we match you with a supervisor who has similar interests as yours. For example, we had one student that was who was interested in using networks for analyzing tennis. Well, tennis is actually an individual game. The network is built not between the tennis players, it's built as the tennis players progress from one level to the other. So it's actually, it's ego network, what we call, right? The personal network of a tennis player. And it's a very unique interest, very unique niche, because it's hard. I mean, even if you find somebody who does sports analytics, find somebody who does tennis analytics, it's not that easy. Well, we actually, through our partnerships with Mdna, we have found someone in Europe who does tennis analytics. So this person is actually writing her diploma with that professor. So that's what we do for our students in terms of matching your skills and interests to professors from all over the world. Now, I want to encourage you, if you're here, you're interested in data analytics, okay? And this is the case of United Kingdom, but it's actually very similar where the demand for data scientists, data engineers, biostatisticians, whatever people call themselves, labels can be different. The set of tools is actually very much the same. The market is growing very, very fast. And not only is the market growing, there is demand for these professionals in all areas of life, in academia, in business, in governmental sector. And because there are not enough people who do analytics, those specialists who are so good at what they do, they freely move between those sectors, becoming actually even more in demand. Because knowing how academia works and how to ask academic questions, you move into business and you make much better decisions. And knowing how business works, you move into governmental sector, and then you make better decisions to serve the businesses and the people from the governmental standpoint. Now, the future of network analytics looks actually even more bright, because it turns out that the job market prognosis for network analysis is even more optimistic than for the data analytics market in general. Why? Well, because networks is a very unique type of data, right? There are many types of data, but networks is a very unique type. If for any regular data analysis, the unit of analysis is one point, one person, one company, you aggregate them together, you calculate averages, or you're trying to learn something about them, but it's one person, right? Well, none of our decisions are independent, right? They depend on the environment we're in, on the people we talk to, on the companies we work in. Networks allow you not to only trace those dependencies, but explicitly model them. So those of you who know something about data analysis know that most methods require that data be independent. We call this IID, independent identically distributed. Well, it turns out for network analysis, it doesn't need to be independent. And as a result, we can use networks in all areas of life. In fact, we can't use regression that's so popular in business everywhere. We can't even learn machine learning everywhere, but networks we can, okay? And so what's network analysis? It's actually a field that develops relational or connected data. So those little dots, we call them nodes, and there are ties between them, right? So connecting those people, and absence of tie is also a tie. We call this a null dyad, which can teach us a lot about why do we not have ties when we should. And any flow of information, resources, activities, attitudes, affect between two nodes, we can actually model, okay? And our programs are explicitly teaching network analytic approaches. There are only 6 programs in the world that specifically focus on networks. We are one of them. Well, we consider ourselves as one program, right? But now it's 2 different programs. In some other programs, like University of Groningen, they do have an excellent network program, and they have a PhD network program. They don't have a master's level network program. They teach networks courses on the master's level, but they don't have a program dedicated to that. So if you're someone who wants to work in the business and you want to know network analytics for business, there are not actually a whole lot of options. So without relational analysis, without understanding how the company fits within the industry and all the other actors around it, it's very, very difficult to make the right business decisions. So business decisions fail because we're not using the right tools, with the right data to analyze it. And network methods allow us to do that. Here are some, very cool looking networks that are actually built by someone else, and they're classic examples. I just want to show you how cool the pictures look. Here is a high school in the United States, and without much training in networks, you can tell these students are broken down by race. I don't know which race is which color, but you can tell that races are hanging out together. So network analytics can give you a lot of information that other tools can. And of course, the Trump election is no longer relevant because now we have Joe Biden as the president of the United States. But when Trump won 4 years ago, well, a little bit over 4 years ago, it was a lot of surprise for many people. Well, I want to say that network analytics, network analysis, was actually what predicted Trump to be a winner, first of all, before the election. Second, it was actually March 7th, which is 6 months before the election. The election that year happened on November 7th of 2016, so 6 months prior, and even before Trump was nominated as his party leader. Okay? The Ebola virus was stopped with network methods. It was network analysts who found the patient zero, who infected everyone else, cut out the necessary ties, and stopped the Ebola. So network approach applies everywhere to all areas. I'm not going to go too much into it. And I'll just talk about, actual relevant to the program things, right? First of all, the cost of relevant programs. Region is a key factor. So we do have some competitors in Europe, but of course they're very small and they can't accommodate everyone, and they're also much more expensive. When you look, those actual cost per year, not per program. Our cost for the Coursera part is listed for the entire duration, for the entire program. The United States programs are much, much more expensive than ours. So we offer the best of what a world education, a world university can offer in data analytics, but because of our location, we are actually much more competitive. And so we offer that unique specialization network analysis. Not only we're talking about data analytics and making sense out of data, on top of that, we also have network analytics. So we also have competitive pricing. We do have a research laboratory. So if you're interested in research, you can join the research lab and become a part of the research group. If you're interested in going to business, we do have business analytics track. So it's actually a multitude of tools that are all joined together to give students the best experience. Now, if you're thinking, well, this program is for you, okay? Well, first of all, those of you who are not quite sure, is it analytics, is it applied statistics, is it data science? Again, be careful when looking at the title of the program, because lots of people would just call, what we teach you the program in Python, the data science, okay? So lots of people mean different things by those names. There is nothing wrong with that. It's up to you to make the right decision if this program is for you. I do want to say that lots of statistical courses are usually taught in math or economic departments, and they're limited to mathematical courses, formulas, and derivations. Quite a few students hate statistics because they think we're going to be proving central limit theorem. No, we don't prove theorems. In fact, mathematics is not a required part of the curriculum for us. For those of you who want to learn mathematics, of course, we offer that as part of the program. But we are learning the applied approach. We are learning how to make sense of the results that a particular tool gives us, okay? The focus is on the data because data is a snapshot of what is going on in the world. So we do teach students to understand the data, and we do teach the advanced methods. And like I said, don't get yourself distracted with buzzwords, because you just need to understand what it is that you want out of the program. We are part of a broader faculty of social sciences committing to data science. And so we do belong in the top universities in the world and otherwise. I also want to say that our program is one of the 4 Russian programs that's listed by KD Nuggets rating of best European programs. So, I mean, I'm really proud of that because, let's say, Faculty of Computer Science and Data Science program is not listed in VIA, even though it's a rating of data science programs. And we actually offer a variety of career tracks. So it can be data analytics anywhere. It can be statistical consulting for major firms, or it can be a background for PhD studies. Here's our faculty. As I told you, we bring faculty from all over the world, United States, Austria, Slovenia, Hungary, and those are the top people in their fields. I mean, it's very difficult to find a university where you'll have all top stars working at the same time. Usually each department has 2, 3, 4 stars. When I was studying at Indiana University, I have a master's degree in applied statistics. That was a degree founded by Professor Wasserman. We did have a couple of big names, but the rest of them were young assistant professors that were all trained, in the same university. So they didn't have all that wonderful variety of skills and experience to offer. So by bringing the world-renowned faculty to our program, we are really allowing our students to get the richest experience possible. Currently, offline program has 46 students, 6 of them are international, we have 40 graduates, and they come from all fields of study, starting from the medicine, ending with law. Some of them have mathematics. So we have some students who have all of the mathematics, and we have some who have never had any mathematics. They're equally successful because if you know what you want, we will teach you the right tools. The student success, there are too many stories to share. But for example, here's a story, and I will actually click over to show you the story. And I will have to reshare the screen. They took prizes in two international study competitions, actually 4 in total. They now have won 3 Kaggle competitions. Those of you who know about Kaggle know that it's a huge data science community, about 3 million people. So hundreds of people compete in these competitions. Our students have taken a prize place either first or second 4 times. Now, the one very special competition they just won was the one on the COVID symptom data challenge, where they actually done better than Virginia Polytechnic, University of Washington, and Massachusetts Institute of Technology, the MIT. So now they are not mathematicians, they are not data scientists. They actually both had sociology as their background, but they've learned the tools to do better than technical people from the MIT. So I think that's just shows you the quality of the education that we have in our program. Now, here's another student. He was, that's Russian intellectual game, he won last year. And of course, our students quite frequently win top prizes at HEC student paper competitions, research paper competitions. We allow our students to travel all over the world. I will not stop too much about that because right now nobody is traveling anywhere. We are stuck with COVID. And we have lots of career opportunities. Most of our students, I would say an overwhelming majority, are gainfully employed by the time they finish the program. Many of them start working even before they finish the program, right? We don't recommend that. I tell students, this is not going to be easy. Please spend some time studying now. By the time September comes, they're already employed. And like I said, we do have a lot of advantages. We offer mathematical disciplines if you want them. We offer programming skills. Again, we give you everything you can possibly carry. So it's just, you can take advantage of everything that this program has to offer. Now, some of the sample courses that are listed probably don't say much to you if you haven't done any data analytics. So I will skip that part. I will also skip the gossip because it's in Russian. But here's one of our students. He's actually a physician, a medical doctor by profession, who came back to master's program to learn analytics. And he was just sharing how happy he was. I mean, those of you who are in Russian can read this right here. And basically, what I want to say is we want you to be the best that you can be. And in fact, our motto right here, this is the universal language of math. Those of you who know this, No, this is the average, formula for average, and here the universal motto of our program is be greater than average. So if you want to do that, we'll help you to get there. So I do have a little bit about comparing the two programs, what they are about, but let me stop and actually answer some questions. And here's information about the scholarship to pursue the program. There is no such a thing as a scholarship. We do have tuition discounts. I don't know if it's the same as scholarship. It's not like we give you money. We actually make you pay less, okay? And the Coursera platform for online programs has a universal discount based on the region. So depending on which country you're from, you can qualify for discount. And you can look up the information on site. It's anywhere from like 5 or 10 to 20, 25%. For the offline program, we do have a limited number of tuition discounts or private scholarships where we actually just pay for the students' education based on merit. So when we have an excellent student that we really want to get our education, we actually either give a large discount or we find a sponsor that pays for them to go to school and get education, because we understand that for some people it's actually not that easy to pay for the education. Here's another question: how can business make use of network analysis? And can I use specific example? Well, in end of March, beginning of April, on Coursera platform, we are offering a specialization. It's 4 courses, and they're actually concentrated on business analytics. So it's called Network Analytics for Business. So because it's really a lot of what happens in business is about networks, and network tools are not used enough. Networks mean personal connections of people. I mean, have you seen people around you that may not be the brightest and may not be, the most educated, but somehow they move up the company very quickly? They can build relationships. We often use the example of the Medici family because everybody has heard of Medici, right? We don't know why, but somehow we've heard about them. Well, it turns out that in the 15th century Florence, Medici were not the richest, they were just the most connected. And because they were connected to everyone, we have heard of the name Medici. They came to power because of their connections, not because of the money they had. Money come and go, but connections stay. So in business, we can use network analysis on the very low level, which means on the micro. We can examine relationships between people and see how that makes each individual and the company more effective. We can also study groups and their connections. We can study organizations and how they're connected with each other. And of course, we can study entire industries. And in our work of the lab, we actually had projects that examined both individual effectiveness and the company effectiveness. In fact, we just finished a project that looked at the entire industry, automotive industry, and we looked at some dealership networks and how the cars flow between networks to see whether or not that's an effective way to utilize the connections that dealerships have with each other. So in business, there are lots and lots of opportunities. And again, as I said, we are offering a specific specialization cost, $49 for the entire 4 courses. You get the certificates, and then if you decide to come back and get the master's degree, these courses will count towards your degree. We do have more questions, process of education at the 2 programs in more detail. Well, let me actually just show this to you. Now, why did we open a new program? Well, I would have to say that the original program, the offline program that we opened, appeared because we wanted to train our own researchers for the lab. So it's more academia oriented. Very quickly, it became clear that people who came to us wanted more practical approach. So we opened the business analytics track. And because lots of professionals wanted to get the education without having to leave the work, we actually seriously considered getting an online track only. And when we had the opportunity to team up with Coursera, we of course did. So the online platform will offer the same tracks, but it's probably going to be better for working adults who want to get education in their free time without having to drop everything and come to Moscow to study in an offline program. If you're already in Moscow, then it will have to be a choice of what's better for you. Some people like the freedom of studying at their own time. Some people like to come to the classroom. In terms of quality of education, it's going to be the same. Same professors recording the courses, will have same projects. You will be a part of the same community. We'll have group projects. You will have interaction with offline students. So it just really depends on what suits you the best. So here's a comparison of the two. Now, the applied statistics with network analysis is mostly research. The Coursera-based is mostly practice-oriented. But in terms of the format, of course, is offline versus online, and its methodological approach to data analysis for research, which means for academia, for PhD program, or is it for business and government, right? And the careers for MASNA is mostly for research, for Mdna is mostly business. And of course, there is a little bit of a difference of how we structure the finals. Final exam, we don't have exam. We have the thesis defense, the master's thesis or research article for one program, even though, of course, you can do a project for MASNA program, but you probably will be better off doing a research project. For Mdna, it's applied project. Now, we expect that students that come to our offline program will most likely be international because people who are in Russia can come to Moscow. Only if they're in Moscow, they will probably come to an offline program. But I don't think it matters. Programs are offered entirely in English. And because we always have international students in the classroom, we use English only for all program-based activities. And we do have different tracks. We have computational social sciences that is only offered offline because that's PhD training. You can't really teach somebody as a PhD student online. I don't think you can. That's really more for their offline program. But if you want to do network analytics, business analytics, or maybe just analysis for you to go into the PhD program later, then you can do the online program. Now, how many hours per week are the courses taking on average? So we expect that we will run courses in 6 weeks increments. So each course will run for 6 weeks. It will have one lecture for you to watch in your own time, plus some practical exercises, and one webinar where you meet as a group once every 2 weeks. We will run 2 courses in parallel. So you will have 2 lectures, one for each course every week, and you will have one webinar every week because one week you will have one webinar for one course, another week you will have another webinar for another course. The lecture itself is anywhere between 60 to 90 minutes in length, broken into logical parts of 3 to 12 minutes in length. So you can actually watch it in parts. You don't have to watch the entire lecture. You can study it by topics. And each, of course, topic will have questions for you to test your knowledge and understanding. So you watch lectures in your own time. Then you do webinars at a scheduled time, and we'll be running in 2 different time zones because, of course, our students will come from all over the world. We expect that the average commitment, depending on your level of preparation and how deep you want to go into the program, will be from 6 to 10 hours per week for both courses together. So total commitment is 6 to 10 hours per week for the online program. The plan with students from Africa, Sub-Saharan Africa, we welcome them to the program. They're going to be the part of a program just as much as everyone else, and they will qualify for tuition discounts offered to developing countries. So there is absolutely no difference whether the students come from Africa or somewhere else. We start our programs from scratch. So we don't expect you to know any data analysis when you come in. We will teach you everything from ground zero. Yes, but it's going to be very steep, right?
So you will have to learn quickly. But if you're willing to put the time, we start from zero, we move you to an advanced level where you can win international competitions. I forgot to mention that the two competitions the students just won, each won them $25,000. So $50,000 together for the two competitions that they just took 2 months apart. And that's for people who had well, not zero, but very low background in data analytics, okay? So you can do the same thing also. So we start from ground zero. We expect you to work hard, but you will get there if you want to. Any live classes, yes, those are we called webinars. So you watch recorded lecture on your own, and then you will have a live class for every course once every 2 weeks. Because you're taking 2 courses in parallel, you will have a live class every week, okay? The cost of Mdna program, this is actually, again, it's different based on the region. You didn't miss it because I didn't name the number. Currently, it's 1.2 million rubles for the entire course of study, for the entire program. So it's not by year, it's the whole program. It's about $15,000 at current rates, but that's for the entire program, and that's without any discounts. Depending on the region you're from, you qualify for a discount. So at most it will ever be is $15,000 if you're from developed country. If you're from a developing country or from Russia and the CIS, then you will have a tuition discount. So in terms of savings, I would say in terms of costs, let me show it to you now since you have asked, right? The Mdna is actually less expensive if you consider everything, including the cost of living. The actual tuition for 2 years or for the entire duration of the program is $15,000. For the offline program, it's well, just about 10, right? So it's about 30% less. But you have to account for the cost of living, for the travel. So if you are an international professor, then most likely, I mean, international student, you're most likely going to save quite a bit of money by going the online program, okay? Because of the additional cost associated with an offline. Tuition-wise, and this is based on the rate of 80 rubles per dollar. Right now, ruble is not 80, it's 76, I think. So the cost, the actual price will depend on the currency exchange rate at the moment. Okay, so it's actually, you have to look at, well, how do I want to structure paying for my program? If you're already in Moscow, then of course it makes sense to go to an offline program because it's less expensive. But if you're elsewhere, traveling here, studying here, having to rent an apartment, having to travel to visit your family, most of our students go back home at least once a year, and that's expensive. So that all adds up. And we actually have been quite conservative with living expenses. We think that, I mean, $1,500 is not really that much for tickets, depending on where you are. If you are from sub-Saharan Africa, it could cost you quite a bit more to travel home. So that's something to consider. Do we have curators for the group to whom you can refer to have administrative issues or difficulties? Of course, we do. We do have an excellent administrative office. Currently, it's staffed by 2 people. We have our office manager and her tireless helper. But in addition to that administrative management office, we also have our PhD students that are supervising the master's students. Most of them are graduates of the program. A lot of students who have finished the program have actually become a part of the lab and now supervising our, what we call them, program babies. But in terms of, if you're asking about just administrative question, of course, we have an excellent and very helpful, very supportive administrative office that will be there to help you every step of the way. Okay. Well, one more thing I want to talk about before I let you go. I've already taken up a lot of your time, so thank you for your patience. I want to talk about our community, because another thing that our program offers is this very unique set of people. I did not realize there were going to be unique when we opened the program, but because I'm a psychologist by my first education, Of course, I was running a personality test just to see who they are. And about 80% of them turned out to be the same personality type. They came for this program because it really fit their unique needs and interests. And one thing that's very common to our students, that unique personality type, is openness to experience. It's actually a personality trait, together with introversion, extraversion, and neuroticism, conscientiousness, right? You may have heard about that. Openness to experience is a personality trait. Most of our students score way above average on that trait. They're absolutely unique from one year to the next. We might have more sociologists one year, more mathematicians the next year, but they are adventurers. They really are explorers. They play guitar, they sing, they dance, they volunteer to separate the trash. They work at different companies, they work with children. I mean, they live the full life. And as a result, they're always together in this one little community. We have our own Telegram group. Students exchange, and alumni now, not just students, they exchange ideas, they ask each other questions, they are there to prop each other up, to cheer each other up. And this is the most unique thing I have ever seen. I mean, I myself have 3 master's degrees. I mean, an undergraduate, 3 masters, and a PhD. I have never been a part of such a unique community when I was a student. So this is something that I'm very proud of. And I think that this is something that helps you not only learn better, because students are not competing with each other. They are in this together, and not just during the program, they're in this together for years after. I enjoy watching them talk to each other in their Telegram chat groups. A couple years after they have finished their education, they're working professionals, they often share job opportunities for others, and they're doing all those different things together, right? They in the most advanced and the most interesting parts. They come to us with seminars, they help each other out. So they offer each other lots of exciting opportunities. So next, I have some information about different tracks, but this is something we can talk about later. I want to give you a chance to ask questions if you still have some. Maybe just more general questions about the program, because now that you're making many different choices, right? And many different decisions. We are here to answer as many questions as you have. So we'll talk about tracks in our different Open Doors events. So please sign up and come to our Open Doors to hear more. Are the Mdna students allowed to use the campus facilities? Yes. You are HEC students, just like offline students. In the HEC system, there is absolutely no difference in how you're treated. You have access to all the same resources, like the library, the software, the books, whatever, right? If you want to come to Moscow, you are an HEC student. You will get a student visa and you can come to Moscow. You will get a Russian student ID, which is like awesome thing, and help you wherever you are. So in our system, there is no difference between the students of the two programs. It's just that the means of education that we use, an online platform offered by Coursera versus in-class education, that's the only difference. Other than that, you are fully, to the entire extent, are considered an HEC student. Any other questions?
What advice would you give for someone who is like deciding between various programs? Like there's masters in data science, there's masters in network analysis, there's more mathematical masters. There's just so many, as you were talking earlier, options. What do you have any advice to how to narrow things down? Because it's as you said, like there's a lot of exciting options, but it's just hard to know what's the, in quotation marks, what's the right thing to do.
Well, there are 2 questions that you need to answer for yourself. The first question is, who do you want to be, or what do you want to be when you grow up? It's really an important question because not all people can make a decision on their future profession right away in high school or bachelor's program or even later in life. And I myself have radically changed professions 4 times. I mean, radically. I started with medical school. I was an operating nurse at one point in time. So can you answer to yourself a question? What is it that you want to do? Okay. So if you're going with a traditional definition, for example, if you're choosing between HEC programs, I can't tell you about the rest of the world, but you're choosing between HEC programs, there is a program in data science that's offered by Faculty of Computer Science. That's the second question that you have to ask the program. What is their value proposition? What are they teaching you? And computer science at HEC, they are teaching you the computer side of data science. They're teaching you to program, to write algorithms, to make SQL calls, to basically develop tools, develop the code for data analysis. So you're still analyzing data, but you're coding. You're not looking for meaning in the data. Okay, that's not their job. They have their training sets that they generate themselves. For example, they run lots of simulation studies. And it's kind of just really, they are creating their own data on which they're then analyzing how well their tools are working. So their job is to provide us on the other side of that data science, right? With newest and greatest tools for data analysis. Now, we develop our own tools too. If you look at my HEC page, you will notice that I write in different fields, but all of my work is methodological, where I develop yet another approach to data analysis. But the difference with us is we're looking for the meaning, as I've given you in the example today. So what is it that you want to do? Because if you say to yourself, I want to learn Python, that's not an answer, because we'll teach you Python and they will teach you Python. But what you will do with Python is something that you have to decide for yourself. And nobody can decide that for you. So it's, where is your heart? What is it that you want to do? Do you want to look for meaning in data? No matter where is it applied, right? Is it applied in practice or academia or even in computer science? Or do you want to actually spend your time coding? And some people love to code. I used to be a programmer too. I can see the allure of doing coding and going in the background, and I actually was coding database systems at one point in time. So I know how exciting that is. So what's it that you want to do? 2 questions. What you want to do and what that program that calls itself data something, right? Do they offer something that you want to do? I drill students that apply to a program all the time because I want to make sure that the program we offer is for them. And a few times we had situations when students enrolled in our program, but then they wanted to switch. And just this year, we had a student that enrolled in our program, but switched to a program that's called financial analysis. And I just want to say, how did he get it so wrong? Because we never promise any financial analysis. We teach the tools that can be applied in financial world, not a problem. But we're not here about return on investments or, price to earnings ratio or anything like that. That's not our focus. So he himself did not realize that that's what he wanted, right? So find the answer to these 2 questions. What do you want to do? And what does the program that calls what you want to be offer? Okay, so that's the only 2 advices. The only things I can offer as an advice.
Thank you. Thank you.
Do we have a chat where you can ask questions? Yes. In fact, at the up on top of this chat that you guys all have access to, there are some links. There is a link to our offline program and online program. And you can schedule a consultation with us and talk about your portfolio. And we do have Telegram chats that you're very welcome to enroll. And actually, somebody just posted, Grisha has posted those links. So please join us on Telegram chat. Also, I do have your email addresses, so I plan to have what is called, you know, not weekly, but maybe monthly messages from the academic supervisor, where I can tell you about some of the things that are going on with our program. So feel free to write to any of us. We are very easily Googleable. So you can find us on HEC website, or you can find us on Facebook or any other social media. Because we're networks, right? Networks program. It's very easy to talk about network because everybody knows social networks. Everybody knows Facebook and Contact and whatever else. So you can find us on all those social platforms. Please ask questions anytime. We want you to make the best decision for you, even if it's not with our program. Like I said, there is nothing worse than somebody who comes to a program and realizes that it's not for them later, after they have already wasted time and money. We don't want wasted time and money. We want you to be happy with the program that we offer. Okay? Any other questions? Thank you. All right, well, I hope to see you soon. While you're making decisions, remember, making decisions is difficult. Information deficit, information neglect. Get rid of that information deficit. Try to find out as much as you can. Do not neglect the signals. So if your heart tells you something that, well, this is really not for me, go with your heart. You have to love what you're doing, because otherwise it's not worth it. Even if it's the data science is called the sexiest job of the 21st century, I don't care what people call it. If it's not yours, you're not going to be happy. We want you to be happy with what you do. Right? Okay. Well, have a wonderful evening, day, morning, whatever part of the world you're in. We'll be happy to see you all in our program. But in the meantime, of course, ask us any questions you would like. Thank you for being here with us. Goodbye, everyone.
Thank you.